we want to take a look at just over the type of integration that you might end up with when you do partial fractions, right? This one here, you'll end up with the integral of x plus 2 to the minus 2 dot dx. Right? And here you can apply normal integration. Okay? So you'll get x plus 2, add 1 to the power, divide by the new power plus c. Right? This here is normal integration, right? This one here, whenever the numerator is the differential of the denominator, right? Then we use ln. So that will be ln 5x minus 1 plus c. These are two options, right? We did these last week. Right? This is integration using ln, right? Then a next type of fraction that you might end up seeing is something like this. I don't know if you all remember this one. Anybody recognize that? Think back at differentiation. You differentiate something and you get that. So it's not ln, and we can't use normal integration because remember, normal integration, this value cannot equal to minus 1. Okay? Anybody remember this? What do you differentiate to get this? Anybody online? Tan. Yep, tan inverse. Right? So the integral of this is tan inverse x. Okay? So we have one normal integration, 2 using ln, 3 inverse trace. Right? You will more see these, right? You'll more see tan rather than sine and cos. Okay? And the fourth one, how are we going to integrate something like this? Okay, one that will actually work. Yeah? Right, we're doing integration of partial fractions. Integration of partial fraction. Okay, one now. Hold on. All right, let's say you get something like that. Let's say you get something like this now, right? Can rule one work here? Watch earlier. Can rule one work here? No, right? You can't apply normal integration here. The differential of this is not this, so you can't use ln, and this is not inverse trace. So how would you integrate something like this? This is more like a unit one thing. So you might remember that you could let u equal to x plus 2, and then x will be u minus 2. Okay? So what you use is substitution. Okay? So you'll end up with the integral of u minus 2, because I let x equal to u minus 2. And then here will be u cubed dot, and of course we have to find du dx is equal to 1. That's okay? So the fourth option is integration by substitution, right? I'll just work out this for you. And integrate it. So this is u to the minus 2 minus 2 to the minus 3. So you'll end up with u to the minus 1 minus 2 u to the all right. So in short, how do we integrate partial fraction? Right? So people like Darren who now decide to join. When they integrate in, you have 4 options, right? When they integrate in partial fractions, there are 4 options. Normal integration, integrating using ln, integrate using inverse tricks, or integration by substitution. You gotta remember this from unit 1, right? Make a substitution that when you integrate, that when you substitute, it makes the integral simpler. Okay? So you have 4 options. So when you do a partial fractions that we're going to now, you have to figure out which of these will go. Okay? Copy it down and let's take a look at one full question. I will again. All right, let's go. Let's try easy one first. But yeah, right, I smooth. Oh yeah, no, let's try this one. Hold on. Yeah, that's the one. That's what that's showing. I'm talking. Yeah. They know I don't very well. Why take it all the time from my place around the other fast. I look for the airplane and see it, and like next morning, I see somebody saying 2x added wrong, I'm saying, but it's 2x plus 2x and I say added, right? And I write back 2x. Can you believe I'd rather delete that one time? All right. Finish? Finish? Right? So all we're gonna do is integrate partial fractions, right? And you have four things when you break it up into the partial fractions, you have four options: normal integration, integral log, trigs, and integration by substitution. You have to figure out which one to use. Okay? So I'm gonna give you one here. Do the partial fractions and then we decide. Right? These questions are 12 marks in total, right? The partial fraction part and then the integration part. Right? But I would put it as one. So question one for us is integrate x squared minus 3x over x minus 1. Right? Question, what's the first thing we did before partial fractions? Before we try partial fractions, there's something we have to do. Check and see if it's proper or improper, right? Check and see what's the highest power here and highest power here. What's the highest power down here? X cubed, right? Highest power up here is. So this is proper. Okay? So just remember these steps. Step one, check to see if proper or improper. Right? Remember, if it's improper, then long divide. After you do it, after you make sure proper, find the partial fractions, right? After you find partial fractions, your third step is to integrate. Integrate each fraction using these rules. Number one, normal integration. Well, normal integration. B, ln. 3, C is inverse. And 4, or D, is substitution. All right? So these are the steps I want to remember when you're doing the questions. right? These questions is always come and there'll be like 12 marks in total. Half a question. Right? Just decide out. I'm ready. So nice. How do we integrate partial fractions? So there are 3 steps that we take to integrate partial fraction. One, check and see if it's proper or improper. If it's improper, we add a long divide. Highest power here is 2, highest power here is 3, so it's proper. Move on to step 2. Apply the partial fractions. When you break up the partial fractions, integrate it. There are 4 different techniques that you could use to integrate. Normal integration, ln, inverse trigs, or substitution. Okay, so try this. Right? Apply the partial fractions and then we'll integrate it. Right? Remember, we have a linear denominator and we have a quadratic. Okay? Let's remember that, right? Right, so we'll end up with x squared minus 3x. When you multiply here, you'll get a squared plus 1. When you multiply here, you'll get x minus 1. Right? It's up to you. You can substitute x is 1 and find for A, x is 0 and then find for C and so on, right? Or if you want, you can expand it and compare it. Okay? Right, good. Right? So what again? So let's make sure I write down correctly. Come on. More than likely, I write down the correct thing. I do the right thing here. I do the right thing here. I do the right thing here. Bx ax squared plus a. Then I multiply this out. I'll get bx squared minus bx plus cx minus c. So what do? We can compare the coefficients and we'll get a plus b equal to 1. Then we will get minus b plus c minus b plus c. Right, yes. Is equal to minus 3. And lastly, a minus c is equal to 0, right? A minus c is 0. So once we reach here, as I told you, 3 equations, we had to get rid of one of the variables. So we know that a is equal to c. That's okay? So now I can rewrite this equation and say minus b plus a is equal to minus 3. Okay? I replace c with a. And now I'm going to add these two equations here. Right? I'm going to add b plus a is equal to 1. So when I add them, I will get 2a is equal to minus 2. I got a to be minus 1. Anybody got that? Yeah? And that means that b will be 2. And then c will be minus 1. That's okay? You all got that? So now, the second part is to integrate now. So we're going to integrate a. A is minus 1. So it's minus 1 over x minus 1. B is 2. So that's 2x. And the c is minus 1. Nice. So I can see the integral here. I can see the integral here, right? What's the integral here? Can normal integration work? No. Because when I bring it up, I'll get to the minus 1. So I'm going to check which one next. Ln. What's the differential of x minus 1? 1. Right? So the integral here will be minus ln x minus 1. Okay with that? I don't have to write plus c yet. I write 1 big plus c, right? Now the problem is here. What do I do with this? 2x minus 1 over x squared plus 1. Any ideas? Check it and see. Can I use ln? No? What's the problem with ln? The problem with ln is the differential of x squared plus 1 is 2x, not minus 1. So the problem is minus 1, right? Can I use inverse trigs? No. Can you use a substitution? That could be an option. But I just want to show you one thing here. I want to show you something here. You all said that the problem with this is the minus 1, eh? Yeah? So can I split this up? Can I write it like this? Integral of 2x on x squared plus 1 minus the integral of 1 over x squared plus 1. Can I write it like that? So I split it up like this. Right? This is the same as this. Correct? So now, what do I end up with? I have minus ln x minus 1 plus, what's the differential of x squared plus 1? 2x. So I can write ln x squared plus 1. You see that? What's the integral of 1 on x squared plus 1? I gave you that. Tan inverse, right? So that will be tan inverse x plus. That's it. Right? I can make it look even nicer and bring them together. So I can bring the minus 1 here, and I will get ln x to the minus 1. Plus means multiply. Multiply by x squared plus 1 minus tan inverse x. So I can make it look perfect by putting them together like this. All right, online. So after you apply partial fractions, don't forget to split them up. Okay? Don't forget to split them up and then run through the processes by which you can integrate. Copy it down. Let's go again. Any questions online? Any parts in a show about? Let me know. Online, everybody okay? Chelsea, are you okay online now? All right, my dog, going again. This one in 10 marks. X squared plus 2x plus 3 all over x minus 1 x squared plus 1. Integrate out there. Yeah. This one is 2016. You have more than one chance in partners, right? Believe you have, right? And we got the lot of this when we go together. Right? It's like how we said that's not, but it's after. Yeah. Can we just check it out? So when you get equal to what ABNC? Integrate it now. Yes, Darian, you're three in the wrong place. Huh? Where's another game I need to do bad? Right? Just for variation, I'm gonna plug in x is 1. Right? You'll get 1, 2, 3, 4, 5, 6. Here you will get 3. So I got A to be 3. I'll plug in x is 0 and A is 3. So I'll get 3 is equal to 3. This is 0. C by minus 1. So I got C to be 0. C is 0. Yeah. Right? Yeah. C is 0, right? So I know A is 3 and C is 0, just to find B. So I just gonna put in 3 numbers. X is 2, A is 3, and C is 2. So I show you the next technique, right? Right? And you could find for B. So you can use any number here. But this is 4 and 4, 8, and 3, 11. A is 3. 2 squared is 4, plus 1 is 5. Plus B by 2. And 2 minus 1 is 1. So 15, 11 minus 15 is minus 4. So B is minus 2. That's okay? Yeah. Now we're going to integrate. We're going to integrate A, which is 3 over x minus 1. And B is minus 2. So it's minus 2x over x squared plus 1 dx. Right? I can take the 3 and put the 3 on the outside. And I will get 3 ln x minus 1. And here, the differential of x squared plus 1 is 2x, so I know it's ln. Right. So I saw some people make a mistake here, Darian. This 3 has to go here, right? So that'll be ln x minus 1 cubed divided by this. Right? Remember to put your modular sign, right? That's okay? Bye. Bye-bye. Trouble? Which one? Okay, I'll check it as now. Next one. I'm gonna give it one a little bit harder. A video, one. You want another one? I think a tree. Lost in my business. Wow. Lost in my business. Okay, this next one here, this is 2017. We can do one more, now we good. Huh? 16, 27. Okay. Yeah. Yeah. We have a same problem, huh? Look at the denominator. X cubed plus 4x. What should you do? Factorize, right? Factorize. So get x squared plus 4y. Right. So the integral of 1 on x is ln x, right? How do we start to integrate it? What to do? Separate it, right? Separate it. Right. Hurry up, finish up that part. right? How are you integrating this one here? What to do? How are you integrating x over x squared plus 4? What to do here? David, what to do? What's the differential of x squared plus 4? So it should really have 2x here, right? So if I put 2x here, what to do outside here? Far half. Right? And now you could use ln x. Well, ln is that here. You could use ln here. Or you could use here. Or you could use here. See if you remember. It is tan inverse. Yeah, remember tan inverse what? See if we can check back the rule. Right? What is here? I don't know if you remember this, right? But if you differentiate this, you'll get this. So if you integrate this, you'll get this, right? So this is the general form tan inverse. What I gave you is when A is 1. When A is 1, here will be 1, here will be 1, here will be 1. Okay? But now they want us to integrate 1 over, I just switching it around, right? 2 squared plus x squared. They want us to integrate that. So if you look here, right? If here is 2 squared, here should be what? 2, right? Here should be 2, so here should be a half. That's okay? So now, what's the integral of this? What's the integral of a half by 2 over 2 squared plus x squared? The integral of this will be a half by, if I have a half by tan inverse x on 2. That's okay? So you must always write it in this form. So make a note of this one, right? Make a note of this for me. Okay, so if you see 4 at the bottom and you know you could write it as something squared, well, when you figure out what squared will give you 4, write it here, divide it out. Right? Because the integral of this is tan inverse x on e. And I would like you here to combine both of them. X over a half means square root. All right. Online, are you okay with that? Alex, Alia, are you okay with that? Jaden? Very x squared. Go on, look as a rule. I root for over a differential and this x on 2. So if you differentiate tan inverse x on 2, you'll get 2 over 4 plus x squared. Right? This should be squared, eh? But that's not what I meant here. This should be squared at x by mistake. This should be squared here. Okay? So make a note of this rule, right? We don't have much time, but I want to squeeze in one more. Yeah? I just go all along, but today I should have. Grazie already and this. Okay, guys, here we go. Here we go. Alright, sign up, click on the group, you will try this one for homework. So, right, try 2018 for homework and I will do the solution and send it, right? Add online, that's it. Couple down and you also log out, right?